Okay, I think we can get started. I see that we have a large number of people joining the seminar. Webinar. We are now up to 190. So good afternoon, everyone, and welcome to 4evergreen technical webinar on the Recyclability Evaluation Protocol. I am Tytti Peltonen, Vice President Corporate Affairs at Metsä Group, and I'm also one of the co-chairs of 4evergreen. And thank you all for joining us. It's actually great to see such a diverse audience from across the fiber-based packaging value chain and also from the circular economy sector. If you would like to ask any questions, please use the Q&A function, and then these questions, they will be addressed in the final part of this webinar. So you are all muted. Let me quickly go through the agenda and introduce our speakers. So first, I will say a few words about 4evergreen and its technical work. Then we have Raymond de Schrever, Global Business Development at Food and Beverage Carton Alliance, and he will tell us about the Recyclability Evaluation Protocol update. Raymond is also co-lead of 4evergreen Workstream 1. Then we have Oana Barzan, a Specialist Development Engineer, R&D at Avery Dennison, and she will present the Part 1 deep dive. Oana is also co-lead of 4evergreen Workstream 1. After her, we have Peter Hengelspa, Product End and Life Compliance Manager, Recyclability at Stora Enso. And he will present Part 2 deep dive. Peter is a co-lead of 4evergreen's standardization workstream. Then Raymond will continue with the Part 3 deep dive, and I will present you the future outlook. Then at the end, we will have a Q&A session. And if you would like to ask any questions, please use the Q&A function, and they will be addressed in this session. So I will start with 4evergreen. So 4evergreen is a cross-industry alliance of more than 110 member companies, representing the entire life cycle of fiber-based packaging, from raw material suppliers to brand owners, recyclers, technology providers. We have an ambitious mission, but it's also achievable. And the aim is to raise the recycling rate of fiber-based packaging up to 90 by 2030. And before we get started, I would like to remind you of another key moment for 4evergreen. Our annual conference will be organized in Brussels on 19th November. It will be a great opportunity to dive deeper into our technical toolbox and also connect with the value chain. So you can see the QR code here, and you can use it to register the webinar. Then today, our objective is to present you the Recyclability Evaluation Protocol. The protocol, it's a practical, science-based tool that helps to reach 90% recycling rate for fiber-based packaging by 2030 in Europe. So you will be hearing from our experts the latest updates, and they will also explain you how the protocol works. We will start by looking at how the protocol fits into the bigger picture, the 4evergreen technical toolbox. And as I said, the mission is to reach 90% recycling rate for fiber-based packaging by 2030. And to make this happen, we have developed a technical toolbox, a set of practical, science-based tools that supports circularity at every stage of the value chain. And we have three main tools. First one is Circularity by Design Guideline. It helps packaging designers to create recyclable packaging from the start. Then the second one is Guidance for Collection and Sorting. And it ensures fiber-based packaging is captured, sorted correctly, and also routed to the right recycling stream. And then the third one is our Recyclability Evaluation Protocol, which is the focus of today's session. And what it does, it provides a harmonized, lab-based method to confirm recyclability across the three different recycling routes. So conventional mills, flotation de-inking mills, and specialized mills. And then what makes the toolbox unique? It's the holistic approach. The circularity by design guideline, first it anticipates the protocol's metrics or criteria, so that design score well in recyclability test. Then the protocol validates those design choices with objective lab testing. And then we have the collection and sorting guidelines or guidance that ensures that recyclable packs actually reach to the right mill. And then together they form a closed loop system that supports innovation and product development. They also support compliance with the EU packaging and packaging waste regulation, and also with the EU's climate and environmental objectives. So why this protocol is so important? It's because it gives the industry a clear, objective yes or no, and a score of recyclability. It also reduces uncertainty. It can support innovation and helps us to move towards a truly circular economy. And now I would like to give the floor to Raymond, and he will present you the protocol updates. So over to you, Raymond.
Thank you, Tuvi. And also from my side, a warm welcome to the audience today. Probably because I'm the oldest one on this side of the screens, that I have the honor to bring you back into the history of how this protocol was developed before we dive deeper into these separate parts. Although history, it started in 2020, so not that far away. And I think the most important decision that was made at that time by the 4evergreen community is that we divided the paper world into three major processes, so that every paper could find its way into one of these processes. And of course, the most well-known process is the paper mill with a conventional recycling process. They handle the most paperboard packaging board in the market today. It's quite a straightforward technology, and they handle let's say, the most pure and fiber-based packagings in the market. This group was quite easily to define. That's why we started also with this typical process within 4evergreen. The second process, to keep especially the white and bleached fibers into the process, into the loops, is the paper mill with the flotation de-inking recycling process. Of course, specialized in removing inks and coatings, ideal for the printed and lightly coated packaging, but of course, not that suitable for the more complex and metallic layers. And for that one, we have the third paper mill with specialized recycling process that can handle these more complex multi-material packagings, like there is the liquid packaging carton. And they use maybe not only advanced processes, but maybe more advanced process parameters like time, temperature, maybe pH, to recover these fibers. Sometimes they look very close to the conventional process, but basically they need more time because they handle, let's say, double-side coated materials or a bit higher wet strength materials. Oops. So why did we decide that we need the European Recyclability Evaluation Protocol? But at that time, I'm talking about 2020, the focus was mainly on circularity. Circularity was the buzzword, and of course, recycling is part of that circularity thinking. But we need to be careful that our paper circularity is not infinite. And it's important that we have new fibers or recovered high quality fibers to enter the loop. Because with our ambition to recycle better and more, we also see that the fibers are coming more often in the loop of recycling. And we all know that every recycling loop, the fibers will degrade a little bit in quality. So it's important to address this, and I will come back to that later in part 3. Another point is that the amount and variety of fiber-based packagings in the market massively increased, often to replace other types of packagings with more complex material. And that also needs the fact that we need to adapt the recycling procedures and the processes so that we can recover these more complex covered fibers. And last but not least, the industry is constantly innovating to increase the recycling rate, because that's an important parameter, especially in 2020. That was also one of the buzzwords. Recycling rates needs to be extremely high. But saying that, we were lacking a uniform and harmonized methodology to rate that packaging, to give it a ranking. And therefore, we decided to develop this Recyclability Evaluation Protocol. As said, we started in 2020, and between 2020 and 2022, we developed a protocol for the conventional process. And that resulted in a beta version that was released December 2022. In 2023, it was decided that we make one document or one work where all 3 parts, so conventional process, flotation deinking process, and specialized process, are included in one big work, one document that can be handled by the industry. And part 1, in the beginning, we thought it would be quite easily because there was already a beta version, but it appeared to be one of the most complex parts to handle. In the end, it resulted in a launch of the protocol version 1 in January 2025. And there is an update now in April 2025. It's important to know that the parts 2 and 3 started in 2023 because where the buzzword in 2020 was maybe circularity, in 2023 it was PPWR. And that is also one of the reasons why some of the protocols seem to differ a little bit from each other, but in the end they are all aligned. This is what you will see when you open the web page of 4evergreen, the part on the right side with the green blocks. And this is the overview of what we have today. So the top 3 green boxes, the green, the light green, and the probably dark green or maybe black, is the test methodology for part 1, part 2, and part 3. Here you can find how to test your packaging. And below that, in the smaller boxes, you will see the annexes of these 3 parts. What we decided to do is to have a full set of annexes, so you don't need to jump between annexes, because some annexes, like for part 1, are also similar for part 3. But one set of annexes is completely for your assessment, for your testing. Then in the middle, you see boxes with the report. So the lab needs to report in a certain template. And with a template outcome, you will go to the Recyclability Evaluation Protocol and the scorecards. And at the bottom 2 or 3 boxes or links. The scorecard is basically an Excel where you can fill out your results, and then you will get a scoring. And how this is done and the background and why, you can find in the evaluation protocol. And then on the bottom here, you can see a template how you can deliver as applicant the data to the lab. To make it easy and see where your packaging will end, there's a sort of guidance for this evaluation that is divided in 2 parts. You can see on the left side the most regular one, the paper and board collection in the most European countries, and this is an average. I mean, there are countries with a different methodology. On the right side, you can see the collection with a lightweight packaging. Go back to the left, you can see that the paper and board is in the end sorted into 2 different ways, into the flotation deinking, and what's left over is going back into the stream that ends up in the end in the part 1 conventional mills. Flotation deinking is ending up in part 2 flotation deinking, of course. Then the lightweight packaging that mostly covers, let's say, the more complex papers like liquid packaging cartons. There are two options. They are sorted out if it's a liquid packaging carton in part 3, the specialized process for liquid packaging cartons. And you can see there's also a light shaded box that other materials that can go with the lightweight packaging are ending up in a specialized process FBCP, fiber-based composite packagings. At the moment, we don't have a protocol for that, but at the moment we are working on a draft with part 3 that will describe also this typical material FBCP. And in the end, if that one is also green, only one box will be open. That's all other papers, because with this we cover the household materials 501, 502, 503, but we don't cover the other materials, and that is planned somewhere in 2026. And with that, we start the deep dive. Joanna, up to you.
Hello, everybody. It's nice to see such a large audience today. All right, so I will take over and explain a little bit the technical aspects of the recycling methodology for mills with conventional process. As Raymond described before, these are the types of mills that handle the largest volumes of fiber-based packaging, but also in the simplest processes. They're essentially packaging like corrugated boxes, brown paper bags, and so on. These type of mills can also handle and recycle white fiber-based packaging that end up in this type of processes, although it's not ideal if it happens, as we want to recuperate as much as possible of the white fibers in the deinking flotation processes. As we mentioned, the simplicity of this process lies in the fact that it's basically consisting of 3 main steps, which are representative in the laboratory methodology as well. The 3 main steps are the repulping, where essentially the paper is mixed with water and blended into a pulp. Then this pulp is passed through a screening step where all the non-paper components are separated from the fibers, and the fibers recuperated from the screening step end up in a paper making process where new paper is made with the recycled fibers. While it seems very simple in theory, and it is in concept, in reality, there is a very large complexity that happens behind the scenes, and especially in the methodology. Here you have a very quick schematic of some of the details that come with these steps, but also some of the analysis that can happen in each one of these steps, so that we can determine the recyclability of a package that goes through the process. There are still some optional parameters in the methodology, like measuring oxygen demand consumption, which is still, it's possible on request, but it's not part of the final evaluation scorecard. But there are also permanent parameters that are now in the final evaluation scorecard, and those are total screening yield, which essentially determines the percentage of fibers recovered by the end of the process, dissolved colloidal substances, which indicates what is the quality of the water that is left over in the process, visual impurities, evaluating how clean is the recycled paper, and sheet adhesion, evaluating how tacky is the recycled paper. If we go ahead and deep dive a little bit into these key 4 parameters, I can explain a bit better that the total screening yield is calculated based on the accumulation of the coarse rejects that have been separated in 2 screening processes, a coarse screening process with very large holes in the mesh. 5 millimeter particles are separated here. Particles like pieces of films, foils, metal clips, screws, plastic windows, tapes, and so on. These are the type of materials that come out in the core screening. And then there's a separate step called fine screening, where the smaller particles are separated, like fiber agglomerates that weren't properly disintegrated, adhesive particles, and so on. The accumulation of these 2 parameters lead to the calculation of the total screening yield. Another parameter is the dissolved colloidal substances, which essentially is the evaporation residue that remains in the water after the process is done. The visual impurities means the operator in the lab will evaluate the quality of the recycled paper visually with backlight, front light, and determine how much contamination appears in the recycled paper. And the final parameter, the sheet adhesion, is where the operator evaluates how tacky is the recycled paper. Now, the recycled paper is made between two other sheets, a cover sheet and a carrier board, and the way that this is removed from the two cover sheets is how the sheet adhesion is determined. There is a knock-off criteria with this parameter, essentially meaning that if the sheet cannot be separated from the carrier board and the cover sheet, then that means that particular product has failed the recyclability evaluation and no testing is needed further. Now, all of the aspects that I described so far are part of the original base protocol that Raymond described. But in early 2025, there was a set of new publications, documents that were very valuable. A lot of work went into them. One of these is the annex attached to the protocol, and the annex provides a very detailed work description on how to follow these procedures. And I have a couple of examples here. One example would be, in case we need to evaluate the reject, there can be a lot of materials on the screens that have been collected from metal foils, plastic pieces, adhesive particles, and so on. And this detailed work description provides a very thorough analysis on how to look at it, how to evaluate. There's pictures, and there's a systematic approach on how to look at every one of these components when the evaluation is done. This is a way to help improve the robustness of the methodology. The same way the visual impurities analysis can be done. The detailed work description contains examples with pictures on how each and one of the parameters can be evaluated. And another very important aspect of this annex is the fact that now we have a very detailed description on how to handle complex packaging. A cardboard is simple, but there are all kinds of complex packaging out there that are being produced that contain other type of components like plastic inserts, plastic windows, metal clips, components that can be manually separated from the package. And this annex describes how to properly evaluate that particular package, how to separate the components, how to weigh them individually, and how to prepare the sample for the analysis before you even start the whole process of the recyclability evaluation. Another element of this annex is now the addition of packaging aid sample preparation, and that is when you have components of packaging like tapes and labels that can be evaluated individually of the main package, because when these products are being manufactured, it is not known where they end up or how much an end user, like in the house, will use. Like how much tape will you apply on a package when you prepare it for a shipment, for example. So this section of the annex helps evaluate those particular components, even when we don't know where and how much they will end up. And it recommends the substrate on which they should be applied, a representative substrate. It recommends the proportion on which they need to be applied on this representative substrate, how to prepare them for the test, and so on. So there's a lot of information in these annexes, and it's very valuable to follow the process thoroughly. And once everything is completed, you end up with a final scorecard, which again is quite complex, but it is based on the 4 key parameters that we've already discussed. The final score is going to be in a range of -100 to 100. If it is from 0 to 100, then the product is deemed technically recyclable in a recycling mill with a conventional process. If the score is negative, the product is not technically recyclable in a conventional mill. However, that doesn't mean that it cannot be potentially recyclable in other types of mill. So the scorecard only evaluates the conventional mill recyclability. That's it. And I will conclude this part by showing 3 examples of how to use the scorecard. I think it's a very nice template that is available on the website, and anybody can play with these key parameters to see how they will impact the final score. And I'm going to show you 3 examples. One of them is of a package that has a final score of 87. This scorecard does not only provide the final score good or bad, but it also gives recommendations where needed, if needed, on how to optimize it if somebody would like to do that. For example, here, a package with a score of 87, it performs well on all the key parameters, and the final recommendation is that, okay, you don't need to optimize this further. If you have a score of 32, the conclusion is the same. The package is technically recyclable. However, there are a couple of parameters where there is a bit of space for optimization, and this is what the conclusion of the scorecard says. If you want, you can provide a bit of optimization, in this case to improve the yield, because this particular product needed extensive time to achieve a good disintegration. The final example that I have is on a product that has a very high sheet adhesion. We saw the sheet being torn apart in a few slides before. Essentially, this is a knockout criteria. If you have a negative score or a knockout criteria, the product has failed the test and it's not technically recyclable in this type of recycling mill. Once again, it doesn't mean that it cannot be recycled in another type of mill, but for this particular process, it is not compatible, and the product has failed the test. So I hope everybody will have some fun with the scorecards. I think it's quite interesting to see how each parameter can play a role in the final scoring system. And I will complete my part with this.
Yes, thanks, Joanna, for driving us through the conventional process scorecard. And I will then now continue with recycling mills with flotation deinking process, where we have been, as Raymond has explained you in the introduction, that we have been starting a little bit later in the process in this alliance. So we have been building on existing documents already, which you will see then also in my part of the presentation here, so that we have been using well-established approaches and yeah, combine those in the flotation deinking process approach and scorecard. So, but let's start yeah, in a similar way here for the flotation deinking process part here. So the purpose is here to assess the technical recyclability once such a packaging would face then the recycling conditions in a flotation deinking process. So those processes are typically handling then graphic paper, which is then in the EN 643. So this is a grade specification for paper for recycling. So those grades that are intended for deinking then are specified in those in this grade list, and there the inkability is a requirement for the graphic paper, and we can also then assess with this approach here how a packaging would behave in this type of recycling process once it ends up there. So the typical products that are in scope of this evaluation protocol here are white or printed packaging, so folding cartons with light brightness requirements, so with high brightness requirements. So there are quite some products out on the market which are of bleached fibers and a very valuable material that receives then also then quite some attraction then from the inking industries, which are really then looking for a high value material then for the input of such processes. So the special thing here, or the goal of this flotation deinking process, specific one, is to remove the inks and the impurities. Similar, but with different technologies, and to increase then the brightness then here for the specific purpose for various paper applications. So this takes us here a little bit then now to the practical process visualization here. So what is very similar, you have heard then already in the first part, is the approach that you are looking at the repulping behavior, but the specific thing here for the flotation deinking process, that those recycling processes that they typically use high consistency pulping stages. That means that the consistency is using then higher consistency conditions, meaning a lower dilution in the repulping stages, which is then significant different compared to the conventional process. And also in those processes, typically chemicals are used to support then the release of the ink, which is a specific thing here typical for the flotation deinking process. So this is what you see on the left side. And then the core process for the flotation deinking evaluation is here the so-called flotation stage. So this is a process where air is injected into this high diluted pulp, and then the air bubbles are rising up in this suspension, and then they are collecting and removing then with the foam on top then the ink particles or hydrophobic particles in general. And what you can see then on the right side, an outcome, and here this example, you can see here some dark spots. Of course, this is not an ideal outcome, but this is something you might also observe with certain inks or certain additives that have been then used for the converting process, that this is causing potential issues then in the quality, and this is what we are investigating with this evaluation protocol here. So the end use of those products, it's quite a range. So it can be then printing graphite paper, but also tissues. And the removal of the ink, as said, is really then the very specific thing highlighted here for this process, which is different compared to the conventional process. So I can skip a little bit the details, as Oana already quite nicely shared and presented. Then here the individual parameters of the first batch. So on the next slide, I will show you some more details. So the principle is here that you're running then two different batches. You're starting with one procedure, and then you basically repeat a very similar procedure in the beginning. But in a second step, you are determining then different parameters. And this is then the part of the flotation. But let's have a look at this. So what you can see on the left side is basically the repulping process, just with different conditions, as you have it also for the conventional process. So here we are adding chemicals using a high consistency pulper. And after the repulping stage and after then some water analysis, we are also performing a screening procedure, which is basically based on the experience and the application that we have for the conventional process. So quite similar. What is then specific here in the batch 2 is that after this, again, repulping, the disintegration stage here, we have there some flotation stage after a dilution. We are running this procedure here to evaluate the quality of the pulp. So how well can we remove then the ink and hydrophobic particles from the process? So this is the core element that is specific to the flotation de-inking process. And around those processes, of course, we are measuring quite some different parameters, which are then used for the evaluations and for the results. And this is just here to see, and I think you already noticed that there are quite some parameters and also then shown in an earlier slide. So quite some parameters are considered for the evaluation. So there we have not reinvent the wheel, but we use the existing experience from the conventional process scorecard from the part 1. But we also used existing assessment approaches for the graphic paper, for the flotation de-inking, which is for the graphic paper, has been established on European level and harmonized method since quite a while. And this is something which is then taken into account to finally summarize then those results from the individual batches. For the first one, basically for the screening, for the reject analysis, and the second one for the pulp quality after the flotation. So similar then to the very similar to the conventional process, you can see also here. So the outcome, the overall outcome for this evaluation is then a score, the technical recyclability score here in a range from 0 to 100. So if you have at least 0, this means you're technical recyclable in a recycling mill with flotation de-inking process. And if you have negative results overall caused by individual parameters, then the outcome of the evaluation is not technically recyclable in a recycling mill with flotation de-inking process. So this is something that you have seen earlier, and I would also then like to draw your attention, and no need here to go to the details, but I just want to show again and highlight some parameters that have been included then in this evaluation here. So on the left side, you see here a long list of parameters showing that there are some more parameters compared to the conventional process, but they are also addressing different requirements for the pulp to be produced then during this procedure. So on the left side, starting with the reject from the screening, which you saw earlier, there are also values obtained in the flotation de-inking process. We are also looking at the chemical oxygen demand, at the evaporation residues, at the sheet adhesion. So those parameters you already saw earlier. What is specific then for the flotation de-inking part is then the brightness and the luminosity, in other words, so how white is the material and how efficient the ink can be removed. And to describe this behavior, we have parameters. We are measuring the luminosity of the pulp before the flotation stage, after the flotation stage, And then we are measuring then after then this cleaning procedures in laboratory scale. We are describing then the level of those parameters, and also describing if there's any discoloration. So if you have certain inks, for example, you might observe also a discoloration, and we are targeting a neutral shade of the material. And this is something which is then also addressed with those parameters. Further on, we have a quantification here for the graphic, typically end users then of the pulp, then dirt specks, meaning visual impurities, small specks caused by inks, varnishes, and so on. This is a critical parameter where we have a quantification included then in this flotation de-inking process. And then finally, we are also then checking how efficient then has the ink been removed during this whole procedure with the parameter of luminosity gain, and the filtrate darkening gives us some information whether small ink particles, for example, are accumulating or potentially accumulating in the process water. And those parameters you saw on the left side, they are then used. As for the part one, you have also their templates then available, a scorecard, so you can just fill in this information. You can calculate then based on the formulas that are provided then in an optimized way quite easily the results. And you are summing up basically then all the individual parameters using certain formulas. I just showed it here. There's no need to go here to the details, but they are then following always the logic that you have a certain threshold parameter. So threshold for the part 2 scorecard means it's a minimum requirement. And if you are then moving ahead, you have then also a target parameter, and the target parameter means this is a thing that is the target to be removed to get really the full score. And this packaging has been assessed here. As you can see here, with very good results. So the first part was a screening. There was no issues identified, really good performance, and the overall result then of the evaluation is in 97 points. That means this is a technical recyclable product for the flotation de-inking process. So this was in a nutshell, and I will now hand over to the specialized to have a look at some other aspects that are relevant for this type of recycling process.
Thank you, Peter. Good to be back again. So part 3, recycling mill with specialized process UBC. And this is the definition as you can find it now on the website and in the documents. Probably in the next revision, we will follow the SEN definitions. That will be something like a paper mill with specialized recycling process LPC. So liquid packaging carton will be the new definition instead of UBC. That's what's in the name. So as said, back in 2023, we could not find some common ground on how to catch all the specialized processes into one evaluation protocol and one scorecard. So it was decided to focus at that moment on the specialized processes for liquid packaging cartons, so the used beverage cartons. This was already an established recycling stream and a process, so we could start immediately. Typical products for this process are, of course, the liquid packaging cartons, but also laminated cartons with polymer and aluminium barriers on board. As said at the beginning, my introduction, there's a need for high quality recovered fibers or new fibers to make sure that the paper quality remains the same or even can become better. And the typical quality of these packagings is that they contain liquid, or they're made of liquid packaging board, meaning high quality fibers. That's the reason why this is a special process. It's really important to keep the paper quality at standard. I always like it when it's so simple, paper making, in only, let's say, 3 columns, especially for me. But you saw this one also in the conventional mills and the flotation de-inking. It's the process is quite simple. It's repulping, mostly in drum pulpers or batch pulpers that are using a higher consistency. But in the end, after the screening, you will have the paper pulp that you also have in conventional mills or in flotation de-inking. But what is typical in this process is that you also have a byproduct. And I still make the mistake, I would not like to call it a reject, but it's a byproduct that will find a next step, recycling. And that byproduct is also called polyol, so a combination of polymers and aluminium. That's typical for these specialized processes that they can separate the materials in two streams that both are recycled. That was the reason why we think this should also be rewarded in the scoring. Just to show you that it's not a fairy tale, on the left you can see a bale of beverage cartons, liquid packaging cartons that's going into a paper mill with a specialized process. There the fibers will be separated from the polyol, and a bale with polyol will go to a next step recycling called a polyol recycler. And on the map that's also available within 4evergreen, you can see that roughly 100% of the liquid packaging carton bales will find its way into a paper mill with a specialized process for LPC, but that also the polyol is already finding 70% of its amount in a special recycling process. So it's there, it's increasing, and it's going toward 100%. So having said that, it's important, of course, to reward that into the methodology and the scoring. You saw a similar flowchart before that Oana showed. Here you can see that we have an extra parameter that might be new for most of you. It's called the coarse reject quality. If you want to add the polyol to a recycled content, then you need to describe the quality of that material. And there we introduced a new parameter that's called the coarse reject quality parameter. And it's done by the lab and using also an annex and some lab templates. Typical for LPC is measuring on the pink boxes, meaning an ash content and a tensile index, meaning these two parameters, and we check that with the experts, of course, they say something about the quality of the pulp. So when you are running a line like this and you want to have the quality pulp in your process, then of course you need to have material that has a low ash content and a high tensile index. So that's why we have two extra boxes with two extra parameters to measure. You can also see in brown two optional measurements. One is the evaporation residue and one is the macro sticky analysis. For now, these are optional. They are not used in the current scorecard. Within the new scorecard, we will use them, especially the ER, because it's a yield-related parameter, and also the macro stickies to make sure that we have the proper quality in the end. Again, the overview of the parameters and how they score, slightly different from the other tools, because you see here a line between white and red. Within part 3, there is no gaining points or deduction of points. It's either good or it's bad. And here, maybe we had some slight advantage of starting a bit later, where the PPWR was already more advanced, and we could use the influence of the professors of that work. I also did a gap analysis here, that we try to stay as close as possible to the performance scoring of the PPWR. So we have also what the others have, scoring from 0 to 100, but also a not suitable. The scoring itself is different. So you have either 0 points when you are okay, and you have a knockout when you're not okay. Also, typical for part 3 is that you have this polyol recycling, yes or no. And when we started in 23, we tried to already pre-sort for fiber-based composite packagings by saying, okay, do you have polyol recycling available, yes or no? And with that, we had different options of calculating the polyol. So either there was no polyol recycling available, then in the end, you could maximize your score to the total screening yields of the paper. If there was a data sheet available, meaning that you could provide the lab with extra information, then you had two options. You could score according to a black box or a white box. White box means you have data available and you use the data to calculate your points. I'll come back to that in this example in the next slide. Black box means you need to measure everything. And with that, you also need this typical coarse reject quality parameter that I showed you in the slide before. So here you can see where to end up and how to score your packaging. An example. Coarse reject is 22.4, fine reject 2.9. The level of coarse reject quality is okay. So there's no penalty for visual impurities, no penalty for sheet adhesion. The tensile index is above the 25.8. That's the threshold that was measured using a database. The database is still increasing, but with the data we had, we say that this is the threshold for the tensile index for liquid packaging cartons. Same for the ash. If you are below the 11.7, okay. And here you see this white box parameter, the recyclable rejects. It's 20%. So where you measure 22.4, you would expect 20%, meaning this 20% is the expected amount after an infinite time of using your disintegrator. Then the outcome, there are three possibilities. You will score 75 points if there's no polyol recycling available. We are using that line now in the new update of the part 3 for the FBCP, so the fiber-based composite packaging, because they don't have this next step recycling of polyol. So you will score 75 points. It's not 75% like is mentioned in the PPWR, to be clear. This is 75 points technical recyclability score. If you use the black box, meaning you measure everything, including the quality of the polyol, you will end up with 94 points. And if you use the white box or using your data sheet input, you can score 95 points, meaning that, yes, you can have a very high score, even if your packaging is not 100% paper. And that's, I think, one of the big advantages and the improvements of this, this methodology, that you can include also the other materials that are recycled. And we told many times that there's future work to go, but I will give back to Titi.
Thank you, and thank you all for the excellent, I think, very informative presentations. I hope you gained useful information how the evaluation protocol works. And before we move to the Q&A session, I was just checking the questions, and I see that there will be quite some questions in the Q&A part. So before we move to the Q&A session, I will share with you what's next for the protocol and the toolbox as a whole. And they are evolving to stay ahead of industry needs and regulatory demands. And maybe if you can go to the next slide, please. I think I have some issues with my network. I'm not sure which slide you see, but we are working on different enhancements. So we are adding micro stickers in the recyclability evaluation and expanding part 3 to cover more composite packaging, so beyond liquid cartons. And we are also improving reproducibility of test methods for greater reliability. Then at the same time, in 4evergreen, we also address real-world challenges. We are studying the impact of food residues on recyclability outcome, and then we are refining sample preparation for better reflect actual packaging conditions. And this allows us to keep the food toolbox future-proof, as materials technologies and regulations also evolve. And it also ensures that the toolbox remains the go-to source and reference for fiber-based packaging recyclability and also for the industry. And this work, of course, it supports our ultimate goal that we are ready for packaging and packaging waste regulation to become applicable and to achieve a 90% recycling rate by 2030. And at the same time, it also reinforces 4evergreen, so our role as the leading technical platform for fiber-based packaging circularity. So thank you to all speakers and all experts. Now we open the floor for questions. And you can see under the Q&A section a number of questions. I see that there is something very strange going on my screen, but at least I can see some of the questions. So if I just start from here. So the first question that I can see is that how many recycling facilities are there existing for the 3 different processes? What about the capacities? The packaging regulation expects an industrial scale to be reached, to be rated as a recyclable in reality and not only under lab conditions. Peter, would you like to maybe take this question?
Yeah, let's try. I think as it has been, I think it was Anna in the introduction mentioned. So the majority really of fiber-based packaging is something which is then recycled already today in this conventional processes. So this is by far really the highest volume. And also then when talking about the flotation, de-inking, so there we have an infrastructure which is processing graphic paper, but also due to effects in the sorting, we know that certain types of packaging are ending in the stream. So in fact, so and maybe then before going then here to the specialized here as well. In fact, I think this is a requirement. I think it was also part of the comment here, the requirement for the packaging and packaging waste regulation, then to have then reach specific figures and for the recycled at scale. So it means what we have been contributing here with 4evergreen is to support then the design basically of the packaging, to provide tools to evaluate it, and finally also to fulfill those requirements, which makes the raw material, the fiber-based packaging, also for the recyclers then attractive as a valuable material, fulfilling those minimum requirements, and also supporting that there is that there's now also more investment going, providing them really good trust and confidence also in the fiber-based packaging. So this is something for sure where we need to see also an increasement in capacity. And this is then now moving to the specialized processes. This is what we have been observing in the recent years for the liquid packaging cartons, that there have been investments done in this area to further increase. But I also need to say, of course, that there's something the paper industry is doing and needs to do to further increase the capacity, also to address then this volumes that are put on the market to obtain finally then those requirements there. So there's still some work to be done, but I think we are taking good progress on this.
Good, thank you. And then maybe we continue with a bit similar question. How many specialized mills are there that are specifically designed to process only fiber-based composite packages? And are there only specialized mills that process UPC but can also accept fiber-based composite packaging? Who would like to reply to this question?
I think that would be my line.
Yes, go on, Raymond.
In being part 3 specialized process, that would be my question. So specialized mills, if you limit it to specialized mills processing LPC, you talk about roughly 20 specialized mills in Europe, mostly that are paper mills that run besides the OCC lines an extra line to feed in this higher quality fiber to keep up the quality of their end products. There are not many typical FBCP paper mills. Of course, a paper mill processing LPC can technically accept FBCP, but then there are two major issues. That might be two major issues. One is you need to be sure that your quality is high, because that's the reason why you're running this specialized process LPC. And you need to make sure that your reject or your byproduct can still be processed in a recycling, next step recycling. So that's the reason why we at the moment see a clear separation between processes for LPC and processes for other materials. But dedicated FBCP mills, that was also one of the reasons why it takes longer to start with this typical protocol, are not defined as good as conventional mill or flotation inking or specialized LPC. Hope that answers the question.
Good, thank you. My line is breaking quite a lot, but I think this is not the case for the others. Then the next one that I take from here is that how is fiber packaging with plastic included as a part of the specification? For example, ready meal trays, which have less than 10% of plastic. How is this handled? Is it in the same way? Who would like to take this one? Peter?
Maybe I could start,
Yes,
and then
yes.
others might jump on this. So this is exactly also the purpose then of the evaluation protocols of, let's focus here at the protocol for the conventional process. So here we have defined then with those thresholds on the reject and clear limits also on those thresholds are defining what is then the minimum requirement, or meaning what is the maximum share, in other words, of material which is then rejected in the recycling process, having also some practical implications. So in other words, so with a conventional process, we are having their clear thresholds also defined in the protocol when it comes to reject, what is then not possible then to recover then in the conventional recycling process. And this gives us then the possibility also to make this assessment. So how well is it then matching the requirements? So it means in practice, we have some incentive in the evaluation protocol also installed to make it then for the result. If you look at the detailed results and more interesting to lower than the amount of non-paper part of the packaging, meaning a lower share of plastic will also then in the score be observed then as a positive contribution.
Good, thank you. Then I think, Anna, maybe this is for you. That does part one apply only to unbleached products?
Depends a little bit on the circumstance. So I would say that in general, yes, part one was designed to be able to handle the majority of the volumes which happen to be unbleached products. However, that doesn't mean that bleached fiber doesn't end up there. I can give you one specific example. We all receive shipping boxes at our door every single day. They are unbleached fiber-based packaging, but they have bleached fiber labels on top. So these are the type of packaging components that will end up in a recycling mill with a conventional process. However, if a certain brand owner or packaging manufacturer decides to design a product that is based on bleached fibers, white fibers, theoretically this one should end up in a de-inking mill. And Raymond introduced very nicely in the beginning that little illustration, which you can find in our circularity for design for recycling guidelines, which shows a little bit how the household collection is sorted. And in theory, white fibers should end up in a de-inking mill. In practice, it really depends a little bit on the efficiency of the sorting facility, and that is something that hopefully in time will get better and better and better. So it's not a black and white answer on this question, but I hope I gave you an example on how you can still have bleached fibers in that conventional mill.
And then there is another question on related to partly to conventional mills. So if we have a packaging product recyclable in flotation or de-inking process, but not recyclable in conventional mill, what will be the impact in the launching of the product on the market? Do you, Anna, want to continue, or Peter, will you take it?
Maybe I could talk,
yes.
Because this is a little bit then now leaving the field of, I would say, of the technical aspect. So as it was introduced, so here we are addressing with the evaluation protocol. So clearly the technical aspects then of the recyclability. So as mentioned, we are with this toolbox and supporting then also then the design for recycling, with providing a tool to develop those design tables also then in the future. And this is then the question which comes the next also when it comes into the compliance. So to be put on the market. I think you are all aware of the package and waste regulation, what's ahead of us, and there we are no longer talking about some voluntary requirements. So this has implications really for the compliance purposes to be put on the market, and there you need to fulfill requirements that are currently addressed and defined more in detail. And there, of course, we have used and also brought in our deliverables and into this processes to provide tools to do this kind of evaluation of the technical recyclability of the assessment here. And this means also that you need to have a clear guidance and a clear instructions and which is then the protocol to be applied on. And this is the work that it's currently ongoing, which is not an easy task, to be honest, of course, that we are currently working on there. But in the end, to be put on the market, this is something which is then a requirement from the package and waste regulation. That means then those requirements need to be addressed also in the secondary legislation, where we are feeding into this process, but we are not the decisive body at this stage, and to come to this assessment or to this conclusion at this stage.
So Peter, you already partly replied at least to one of the questions here that I can see, and it is that how will the 4evergreen methodology be compatible with the packaging and packaging waste regulation methodology, and is 4evergreen in contact with the EU Commission or the SEN standardization group? Do you still want to add something? But I think you already covered that part as well.
Yeah, maybe to add, I think this is of course then a clear interaction also in all those processes. That what's currently ongoing there out there in the industry is quite intense. So with 4evergreen, we have of course then also an interest then to take our technical expertise and to the right bodies to make them aware of those tools that are available. But on the other hand, we are also closely following in this alliance, and this is something you might then also expect then for the next publications of 4evergreen, that we are also continuously monitoring what's happening then around this topic in the and also adapting our deliverables accordingly. So this is something which is a quite iterative process, but I think this cooperation in this area and setting their harmonized approaches, this is a key issue and a key requirement where we set here with this protocol. It's also a good foundation.
And then Peter, there is a question to you that when calculating A50 and A250, do you also include the coarse and fine rejects?
Yeah, so maybe to first explain what A50 and A250 stands for. So this is related then to the dirt specs, meaning to the visual impurities in the flotation deinking part. So this is describing then the area of dirt particles with a certain size. So there with this 50, we are describing particles of a diameter, to simplify a little bit, of 50 micrometer, and the A250 is then just the big dirt specs in here. And this is something which is part of the flotation deinking process. So the coarse and fine reject, this is something which is part of the first evaluation. But of course, if you remove something by mechanical screening, that has also then the side effect or the positive contribution that very big particles, which are described with this A250, are also removed. That means, in other words, yes, so the coarse screening and the fine screening have, for very big particles, of course, also then some positive contribution then to reducing then the dirt specs area and the final pulp. But this is for inks, I might say, not really the highest efficiency, this coarse and fine screening. So there the flotation deinking is really the process which is taking, I would say, the majority or the biggest share of removing those particles.
Thank you for explaining in details. Then there's a question that related to the protocol altogether, that how do you envision the protocol to be used in practice by paper producers only or others in the value chain? And how do you see it? What's the vision for this? Who would want to take this one?
I can try.
Yes.
So the protocol is not necessarily aimed at paper manufacturers. The responsibility will fall with the packaging manufacturer and the brand owners who actually place the package on the market to understand what is the composition of their package and where this should be recyclable and with which protocol it should be compatible. So in the end, it's a shared responsibility with all industry contributors who add components to that package, but it is in the end the one that will actually sell the package, that will put it on the market, who needs to provide the final green light or the final certification that will say this is compatible with this particular recycling stream and so on.
Thank you. Yes, that was a very good clarification on that it's really used by the whole value chain. Then there's quite a technical question. If I understand correctly, for all three protocols, TSR is calculated as the sum of CR and 0.9 FR. What does the 0.9 factor represent? Does it correspond to something specific industrially? So who would want to take this one and also explain what it means?
I think I'll take that one. Indeed, in all the three parts, this alpha factor is used. And alpha was introduced in the very beginning when we found out that mimicking a real paper mill, and you can imagine how big this paper mill is, this full process, mimicking it with this small lab standard disintegrator, that there are maybe factors that are not exactly the same as in reality. And it was found out that fine rejects were a little bit higher in the labs methodology than in reality, and that's why because of all the let's say the paper pulp going into the flow, of course, of the process is still losing these fine reject material. So that's why this factor 0.9 was introduced. It's just to mimic the industrial scale. Maybe something that we could discuss is that we might need to repair it a little bit, because if you deduct it, of course, from the fine rejects, you should, or you could also add it, of course, to the recovered yield, and that's now still under discussion.
Good, thank you for clarifying. Then there is a question that under the category of UPC and LPC or LPC is there so liquid packaging. Is there any differentiation between those that contain polymer and aluminium and those that now contain only polymer, or called refrigerated cartons, or do these all fall to the fiber-based composite packaging category? Who would want to address this one? Is it Raymond?
You? This one. Yeah, it's correct. So they both fit in the category LPC, both the acetic and the fresh materials. That's also the reason why this polyol is called polyol. So it's a combination of polymers and aluminium. The fresh packaging, of course, only produced this polymer, but the mixture of that is called polyol and is recycled in the next step.
And then a bit of a follow-up to that to test polyol quality, does it have to be done with the company, or can you rely on one of the certification bodies? Raymond, will you reply to that as well? Yeah.
There are two things that you need if you are, let's say, a paper lab. Two things that you need to do. You need, of course, to measure the amount of the polyol. You need to need the quality. And with the quality, I mean that you need to define the type of material that is used and how that is described in the Design for Recycling guideline. That are the two things that you need to do. That can be done by the lab. The certifying bodies, they only use that information to certify in the end the packaging. You can also use a specific lab that is focusing on, let's say, plastic testing or polymer testing that you can also use test the polyol quality. Basically, if you're doing correct and right, then your assessment or your quality is already described in the design for recycling guidelines. So it could be or should be a desktop exercise if you have, of course, the information available. For instance, by using the data sheet.
Good, thank you.
Yep.
And then also other detailed question that if I send coated paper cup with ink, which test method should I choose?
Maybe
Peter,
if I,
video.
that's
Yes.
yeah, you're getting challenging now with quite specific technical questions, but this is
Yeah.
the purpose also of a technical webinar here. I would say it depends. I think coding is also quite a general terms. I think there are many aspects to be considered. So if you talk about then the technical behavior of an individual product, of course, you can apply basically every procedure. So the approach is for all the protocols, if you apply a certain procedure, this packaging, you get some information how such a packaging, also such a specific coated paper, would behave in such a process. That means if you are applying then the conditions for the used in the conventional procedure, then you can get some information what would be then the behavior, also the expected behavior in such a process. Is it easy? Is it possible to repulp this material? How is it behaving then? Is the coating fragmentizing? Is it not fragmentizing? So same is valid for the flotation, de-inking. So also there you could basically then apply the procedure and then you will see how it's behaving. And then finally also for the specialized process that you could see how it is behaving. So this is a technical protocol which is applied then to the material, and it very much also needs to be considered then in the evaluation. So what is the type of coated paper cups? If you're talking about some one-side coated, meaning a plastic layer on one side, if you have a two-side plastic coated material. So there are quite some things which are affecting then the technical recyclability, then the outcome of this evaluation. But this goes also quite far, much beyond also this. If you talk about then the recycling, also where certain materials are collected, sorted. So this is a wide range of aspects that are addressed. So as for cups, for example, there are also emerging systems for collecting, for example, from different sources, those cups to really focus those streams and send it to recycling processes. So also conventional processes are also then running then this type of cups, for example, in their processes and added to the furnish to a certain extent. This is then causing also no practical issue. So this is very, very complex question also then for the different cups and reflecting also the different infrastructures in the different countries.
Thank you. Thank you for replying to all these quite technical questions. Maybe a more general question that what are the most common reasons for a knockout result and how can designers avoid them? Who would want to reply? Raymond, will you go with this?
I'll give it a try. These I can
Yes.
wait for the part 3. A knockout is always when you're outside limits or when you have the highest level possible. So for visual impurities, for instance, your highest level means a knockout. So how to avoid that? Make better paper or use other materials. Same for tensile index and ash. If you are outside the thresholds, you have a knockout. So you need to design your material within these thresholds. That maybe is a simple answer, but not always that easy, of course, I know. But basically that's the case.
Good. Then maybe another question is that how robust is the correlation between lab-based scores and real mill performance? Who would want to take? Anna, do you want to take this one?
I'll try. This is definitely a very tough question. What I can say is that within 4evergreen Association, there was input from recyclers into this. So it's not a one-on-one direct correlation because each recycling mill has unique features, unique methodologies, and they will be slightly different from each other. So it is almost impossible to come up with a methodology that would reflect exactly what happens at a recycler. However, this methodology is there to give an indication on what to expect as in a standardized evaluation procedure. And of course, a recycler or a packaging manufacturer can decide for themselves a little bit how to interpret the score, because you see that there's a little bit of space in the score. In the future, it can be that certain recyclers will say we can only accept products that, in theory, this is all hypothetical, that we can only tolerate products that have a score above this particular number or so on. But that is something that may be adjusted in the future. So what we can say now is that this methodology was designed to try to reflect as much as possible in a lab facility what will happen in a mill, although it's not a direct one-on-one correlation. But we did get a lot of input from recyclers, and those feedbacks were incorporated in. Any other correction that anybody wants to add?
Maybe in addition, I think just to emphasize that in this during this development, we are really considering also then a single product. I think this is something also that we are taking into account in the evaluation approach. So that we try to express with the score also some granularity. That means that we are taking a single product, we are evaluating the individual product which has a certain share, and then we are also then taking this into account. And in the end, we want to have some clear visibility of the performance of such a packaging. So how well does it fulfill the requirements, and giving now also some, with the outcomes, and also some incentive to further improve, of course, in the performance of such a packaging. So in other words, if you have something in the laboratory scale, I think you can also then, or need to keep in mind also with the industrial conditions you have there, there are also mixtures of materials which are having also some implications. And also this is something where we are not mimicking in each and every detail. This is also impossible and would really go beyond really the capabilities at laboratory scale. We will not be able to mimic each and every step in the process in exactly the same way. But we have been also in the past critically then checking, as explained earlier, whether then there is at least a good correlation, or we see then that the outcome and the performance in industrial processes gives the same information, even if the absolute values might be different. But we are evaluating then also our own approach then again and again during our discussions and checking whether there are certain steps that needs to be added, modified, and so on. But our approach is we try to keep it simple for all who want to have this kind of information, but also, of course, as a fair approach.
Good. Thank you. Thank you for the explanations. Then I think, Peter, again, maybe a question to you. For a two-side barrier packaging, should we apply the conventional mill process in any case?
No, and this is something that, again, to the point, what type of two-side barrier packaging, and this is where the paper industry, we have been observing that there are also now, solutions emerging on the market, which are, differentiating, or where we need to differentiate between also the type of the barrier. So if they are different the barriers in the past, I think it was widely used of polyethylene and other extrusion or laminated structures that have then this water barriers on the board. And as everybody can well imagine, a water barrier is in practice causing there some issues in the repulping, unless you are applying then really specific conditions as we are doing it in the specialized process. So the conventional process, it has been set up and is running under different conditions. So here a two-side coated material with a water barrier, which is resistant to the repulping process in the conditions, of course, is causing or is posing higher challenges. It means that it might take then in practice and also longer times to repulp this material. And this is why this is something where we need to consider then the outcome of such a material in this process also as quite critical to see what is then the amount of barrier, of course, that's remaining, which is one parameter, but also what is then the performance of such material. So is it easy to repulp, or is it then causing some issues, meaning you see then in the results of such a test also. So how well then the repulping will probably work, and this is an indicating also what things might need to be improved. But again, there are new solutions also popping up on the market that are showing then also an improved behavior in the recycling. So this is the innovations that are ongoing in wide areas, that we have the functionality. Of course, you are adding the barrier for certain purposes. You have at the same time a functionality to replace also then other fossil-based materials with fiber-based solutions. But this also means that you need to fulfill then those product requirements, meaning the requirements for functionality.
Good, thank you. Are there any other questions? It's an excellent opportunity to ask our expert technical, detailed questions. While I wait for a while, if there will be other questions, Anna, you wanted to comment on something?
I see a question that is not answered in the list.
Great. Please
will COD and BOD and macrostickies be 3 parameters to enter the next version of part 1? And the answer to that is that COD and BOD are not currently intended to be added to the evaluation scorecard. However, the macrosticky parameter is one of the deliverables for 2025. And as Raymond showed in the future outlook the slide, it should appear in the scorecard in 2026.
Good, thank you for pointing it out. Then there is a new question that if I obtain good recyclability results, score higher than 0 for a certain packaging according to the protocol 1, can I be sure that I would also have good recyclability result, score higher than 1, according to the protocol part 2, or the other way around?
The answer is no.
No.
Black and white. Very simple.
White.
I would say as a general trend, Recyclability Protocol Part 1 is simpler than Part 2, which is simpler than Part 3 in terms of complexity, at least. So if you have a positive score for Part 1, it's almost impossible to know whether you will still get a positive score in Part 2 and Part 3, because the other two parts have a much higher complexity and much more parameters that will contribute to the scorecard. For example, the inking mill will also evaluate essentially the inking and quality and whiteness of the fiber. So, and in part 1, you can have a very good score for a brown paper, which will not be a good product for a de-inking mill. So the answer is no. I think it's important to understand what is the highest likelihood that the product will end up in which recycling stream and then test it accordingly.
Good, thank you. Then for the co-leads, Raymond, Anna, and when are we planning to release the next version?
2026. Do we have an exact date, Raymond?
No. No, we need, of course, to have consensus on the draft. Then we have a full process of voting and accepting and reshaping. So my expectation is that it will be somewhere Q2 2026, at least for the revision of part 1 and 2 and the new part 3.
Good, so something to be waiting for. I see another question coming up. A technical one. Is the sheet adhesion test basically measuring microstickers?
The answer to that is also no. So we are currently doing investigations on this exact question, and we are already seeing that there is no direct correlation between sheet adhesion and macrostickies, which is also one of the reasons that the macrosticky parameters is intended to be added in the scorecard as an additional parameter, because it is not represented yet by the other parameters that are already there.
Good, thank you. I don't see other questions in that section, but I would have still maybe 2 questions to you. What role do you expect this protocol to play in harmonizing recyclability assessments across Europe? Who would want to reply?
Maybe
Peter?
I can, maybe I
Yes.
can take it. Sorry, I was just looking for the unmute button. Of course, this is something where we are, I would say, already then, in this process, the ambition, and this is taking us back then to the introduction then from Raymond. Our ambition in this alliance has been to establish something which is harmonized all over Europe, meaning that if someone wants to put a packaging out there, then there should be also not in Europe then 20 different lab methods and evaluation protocols that then also the brand owners and people in the value chain need to apply. So this has been the approach that we have been looking for, an harmonized approach, which is an industrial, meanwhile well-established protocol. So this is something which is developing, but it is now substituting also in many countries also then other protocols. So if you have then certain requirements regarding recyclability already today, then this is quite often then referred to meanwhile, so as a harmonized approach. But we are, of course, also moving ahead, as we talked about today, also about then this package and waste regulation. So there is now also standardization work ongoing to put it also to another level. That means another level in practice is that there are now standardization work ongoing to standardize then the laboratory test method, and maybe this was not highlighted here in the beginning very much, but in fact also 4evergreen has then worked and established also laboratory test methods for the part 2 and the part 3. So this is something the Alliance has been also then publishing beginning of the year with the evaluation protocol. And now we are in this phase also of putting those documents that are in the industry already widely used and accepted, also to put it to a standard, meaning then to technical specifications or those kind of test methods that are also then fulfilling those requirements for standardization. So this is a step which is already ongoing, and here 4evergreen has set the foundation for those things that are currently ongoing. And for those things that are ongoing, many of you might have heard about this secondary legislation activities from the European Commission. So there we have provided input to these processes, and then by the end of the year, beginning of next year, we will hopefully then see also those things basically then implemented and then also in the second in the technical specifications that are currently under preparation.
Thank you, Peter. And then I have my final question to you. That are you planning to integrating digital tools like AI with the protocol to speed up some technical decisions? How are you utilizing new technologies?
I might take that. Not saying that we are already utilizing that, but you all know that AI, digital image recognition, etc., in, let's say, in the medical world is already making huge progress. Sometimes even making better analysis than the doctor does. Doesn't mean that you need to exchange it, of course. And I can imagine that in our work, especially in the work of the lab, that you can use this technology to, for instance, give a better or more harmonized outcome of the test. So if you have, like said, visual impurities, it's a lab expert-based opinion. Of course, there are guidances to give your opinion, but using AI, I can imagine that you have more strict and more uniform of spread over Europe outcomes of the test, and that would, I think, also contribute to this uniform and harmonized methodology. Not for the scorecard Excel, it's so simple. You don't need AI for that, but this could be an added value.
Good. Thank you. And a big thanks to our experts. There were a lot of technical questions, and I think you replied extremely well. So I hope this session was useful for everyone. And I wanted to thank you all for joining us today and also for your active engagement. Hope that this gave you valuable insights how the protocol works in practice and how it can help us to achieve the 90% recycling rate by 2030. As a last point, don't forget the 4evergreen annual conference on 19th November. You can see the QR code also on the last slide. This will be an excellent opportunity for you to continue these discussions, to explore the full technical toolbox, and also then to connect with peers across the value chain. So we're all looking forward to seeing you there. Thank you. And with this, I close this webinar. Thanks for your participation.
Thank you.